In this video, we're going to work a little bit more with inverse functions. We've defined what the inverse function is and how to find it. And here we're going to show how can you prove two functions are inverse. But as a quick kind of review, a starting place, if we have an inverse function, it's something like this. We have this function f with an input and an output. And if I plug some number a into this function, and I get out a value b, if I have this function, which is indeed the inverse, f inverse of x, which is also an input and an output, if I take this value from b and I plug it into my inverse function, then my output should be this same number I started with. If it's an inverse function, this is what it will do. It will undo the first function and get us back to where we started. So to kind of write this in function notation, I started out and I took f of x and I plugged this value into my inverse function. And I should get back out what I plugged back in. Likewise, if I first plug it into the inverse function, and then I take that output and I plug it into the original function, I should get back what I have. If this happens, these are inverses. And this is what we need to show to prove that two functions are truly inverses. So let's look at a couple of examples. So let's start with these two functions. I have f of x is 3 times x minus 4 squared plus 7, and g of x is 4 plus the square root of x minus 7 over 3. And I want to prove these are inverses. So to prove these are inverses, I want to show that f of g of x equals x, and that g of f of x equals x. I have to show it both ways because sometimes it makes a difference with composition. We remember composition is not commutative. So I need to show that it does indeed work both ways. So let's start with this one. If I want f of g of x, that's going to be f of 4 plus the square root of x minus 7 over 3. And that's going to be 3 times 4 plus the square root of x minus 7 over 3 minus 4 squared plus 7. Yeesh. Let's get rid of this extra on here. So let's work this out. It's not as bad as it looks. Because we have a plus 4 minus 4, those are going to cancel out. So we have here a square root squared. So that again will cancel out. So I'm going to get 3 times x minus 7 over 3 plus 7. And oh look, 3 divided by 3 cancels out. So I get x minus 7 plus 7. So I get x. And that's what I wanted. So I come down here, f of g of x equals x. So now let's try this the other way around. Let's try g of f of x, which is going to be 4 plus the square root of x minus, back up, undo. X is going to be 3 times x minus 4 squared plus 7. And we're going to take this whole thing and divide it by 3. Let's see. F of x has the plus 7. And then the g of x, it's x minus 7. So I forgot that. Let's get that back in. Minus 7. And now let's see what we can do. Well, plus 7 minus 7 is going to cancel out. And then we have 3 times divided by 3. That's going to cancel out. Looking good. So I have 4 times the square root of x minus 4 squared. And again, my square and my square root cancel. So I get 4, not times, 4 plus. You know, half of your problems is just not copying things correctly. Let's go through this again. So this is going to be 4 plus, the square root squared cancel, 4 plus x minus 4 is going to give me x. So once again, g of f of x equals x. So we can indeed say g of x is the same as f inverse of x, because when I did that composition, if I do one, plug the output of one into the input of the other, I switch the inputs and outputs around, I get back to where I started. I've undone everything. That's the beauty of inverse functions. I get back to my x, my input. So let's look at another example, this time with some power functions. Here, f of x, 7 times quantity x minus 3 to the 5th. G of x is going to be 3 plus x over 7 raised to the 1/5 power. Let's show that these two are inverse functions. So again, I'm going to start f of g of x and just do this composition. So that's going to be f of 3 plus x over 7 to the 1/5 power. I plug that in place of my x, so I get 7 times 3 plus x over 7 to the 1/5 minus 3, and raise all that to the 5th power. And I got a 3 minus 3 is going to cancel out. So I got a 1/5 power. Let's just write that out just to make sure that I'm not going too fast. 7 times x over 7 to the 1/5 raised to the 5th, so I can indeed use my properties and cancel those out. And I'm going to get 7 times x over 7, which is just x. So f of g of x does indeed equal x. We're good so far. Halfway there. So let's try our other composition. So let's try g of f of x. Get parentheses going the right way, always helps. So I'm going to do g of 7 times x minus 3 to the 5th. So that's going to be 3 plus 7 times x minus 3 to the 5th divided by 7, all raised to the 1/5. And again, 7 over 7 cancels. 3 plus x minus 3 to the 5th raised to the 1/5. And those two powers will cancel each other out. And I'll get 3 plus x minus 3 is indeed x. So we go back to our composition. G of f of x equals x. These two are indeed inverses. If you want to prove that two functions are inverses, you have to show that they will undo for all values. So that's why we do this composition with x. If f of g of x equals x and g of f of x equals x, we got to try them both. If they're both true, then it's definite they are inverse functions.